Welcome to Part 5, focused on tornadoes and the lookalikes that make accurate tornado reporting challenging. This is a more complex topic, so if you haven't taken a decent break beforehand, such a break would be a good idea before continuing. You're presently watching the 5th video in the training series, representing Part 5 of the training. In the Part 2 video, I discussed what a tornado is and what it looks like. Let's look at the typical life cycle of a tornado, which can last from a minute or less to as much as an hour in extreme cases. Tornadoes usually develop beneath the base of an intense rotating updraft, usually marked by a wall cloud feature. The key to accurately assessing a wall cloud is to look for persistence of the feature, with it being attached to the main rain-free cloud base, and staying with the rain-free base as the storm moves. Most importantly, a wall cloud with tornado potential will show persistent rotation. You may also see cloud shreds beneath the wall cloud, typically called scud clouds, ascend toward it, reflecting upward motion of air beneath the rain-free cloud base. Just before a tornado forms, you may see a slot of clear air or a small break in the clouds west of the wall cloud feature, gradually rotating around it. This is associated with a downdraft on the backside of the storm. As this occurs, the rotation within and beneath the wall cloud may accelerate, and you may see a funnel cloud appear. This is not a tornado until you see dust or debris being picked up from the surface and spun around, indicating the circulation has reached the ground. That's when a tornado has officially formed. Without this evidence, it is officially reported as a funnel cloud. Here's a 45-second video that shows this process taking place. You should be able to see rotation associated with the wall cloud, with the part closest to you going from left to right and the rear part going from right to left. Over time, you'll see a small funnel cloud develop, indicating accelerating rotation. We do not have evidence of a circulation touching the ground, so this is still reported as a funnel cloud. Here we see another rotating wall cloud. Do you see dust being picked up from the surface? There's a dust whirl that suggests there's a circulation that has reached the ground. This would actually be a tornado, even though you can't see a visible funnel cloud. A tornado may be fairly narrow when it forms, but as it matures, it can quickly widen. Mature tornadoes can come in a variety of sizes, from small to medium to large to monstrous. The somewhat narrower cone-like tornadoes are referred to as cone tornadoes, while the wider tornadoes are typically referred to as wedge tornadoes. This video shows some examples of what are called rope tornadoes, which can be the only stage in the life cycle of weak, brief tornadoes, or the last weakening stage of larger tornadoes before dissipation. The rope stage tends to be weaker than that of other stages of larger tornadoes, but damage can still occur. Notice the narrow snake-like appearance of the funnel during the rope stage. There's another type of tornado that is not directly associated with the rotating updraft of a supercell, and that's the land spout, with a version over water called a waterspout. These are sort of a weaker cousin of supercell tornadoes, but they can still cause damage. They're usually too small to be detected by radar and often last just a few minutes. They also occur beneath the rain-free base of the storm, and there's often not a wall cloud feature. Take a look at this video. Would you report this feature as a scud cloud, a funnel cloud, or a tornado? Pay close attention. Do you see debris being picked up at the surface? That signature indicates that the circulation with the funnel cloud has reached the ground. Thus we have a tornado. Without this debris indication at the surface, this would be reported as a funnel cloud. Here is the code word for this video: land spout. Be sure to write it down. Keep track of which word goes with which video. This word goes with part 5 of the training. Now let's turn to the dreaded tornado lookalikes. If you have any question as to why this training is important, it's because of this topic. Lookalikes make it challenging to accurately report tornadoes. Some lookalikes look so much like tornadoes or funnel clouds, especially from a distance, that they often get misreported. There are several types of lookalikes. The most common and most challenging one is the scud cloud. These are ragged clouds or cloud shreds that are quite common near thunderstorms. They are not rotating. In fact, they may be slowly ascending beneath the rain-free cloud base or associated with the storm downdraft. They can be tricky, often appearing like a funnel cloud, especially a long distance away. I've seen plenty of scud cloud examples that look like funnel clouds, but were not rotating or connected to the ground or cloud base. So the best you can do is to try to look for rotation associated with these features and see if they are connected to the rain-free cloud base. If not, then they're not tornadoes or funnel clouds, and they're not dangerous. Let's look at some other types of lookalikes. Narrow shafts of heavy rain can sometimes appear like tornadoes, especially from a considerable distance away, but do not rotate. If there is no rotation of the feature or debris picked up from the ground, then it's likely not dangerous. Mammatus clouds represent an interesting feature. They're the only cloud type that forms from air that descends toward the ground rather than ascending. However, these features are not dangerous, except to pilots, as they can represent areas of severe turbulence. Tail clouds, or inflow bands, can have a funnel-like appearance at times, but generally do not display rotation and are usually oriented horizontally rather than vertically. Other types of lookalikes include smoke or steam clouds, distant cranes or buildings, and a feature called a gustnado, which is the spin of dust or dirt near the ground due to gusty winds. These are usually too weak to cause much damage and are not connected to a cloud above, and therefore are not tornadoes. How would you answer this question? You should never report a cloud formation as a tornado unless you see which of the following. The answer will be displayed momentarily. Pause the video if you need more time. In fact, you need all of these to be the case, so the correct answer is all of the above. How about this question? All of the following are potential tornado lookalikes, except for which one? Well, land spouts and water spouts are a cousin of supercell tornadoes. They actually are a type of tornado. So they're not a lookalike, so the correct answer is C. All of the other answers are lookalikes. What feature do you see in this video? Take a moment to look at it and come up with your answer. Hopefully you see that the cloud feature is not attached to the main cloud base, nor in contact with the ground, and there's no sign of rotation. This is a good example of a scud cloud, so the answer here is D. It's often referred to as a scary looking cloud, as it can be impressive as a lookalike, but it's not dangerous. Now take a look at this 40-second video. What significant features do you see? Hopefully you see both strong winds that's picking up dust, as well as an occasional circulation that represents a gustnado, so the correct answer would be B. You have completed part 5. If you had problems correctly answering the questions in this video, or are uncertain about the material from it, you are strongly encouraged to review it again. Otherwise, please take a short break at least, and then move on to the next video in this series, part 6.